conclusion like this is not a number that could be saved inside a int. So if I try to run it, of course I'm getting some random number. So but I would personally not recommend you to call this as a random number. So hello guys, as I said in the last video, today we'll continue with integers. So let me give the basics like hash include, opening the directory, connecting it to my RAM, and int main. So as I said, integer is actually said to be a 4-byte memory block. Okay, so if I use just a number range, because of course 4-byte means it is a storage, like our RAM is having 8 GB or 16 GB based on your system conditions specifications. So if I allocate a 4-byte out of some particular RAM that you're having, right, just 4-byte I'm taking means I'm telling that a constrained memory space. For a constrained memory space, there is a constrained number limit. Okay, so using that 4-byte, we can just represent only up to this range. So if you use an integer for 4-byte, this is the range that you can obtain, both in the negative side as well as in the positive side. But if you use 2 bytes, okay, you can go up to this range. So now comes a question like, sir, how can we convert an integer to just 2 bytes? Yes, that is a good question to ask, but how means we have certain words like short, keywords actually, short, long, unsigned, long. Okay, so using this we can extend the size specified to an integer. That is, by extending the size specified to the integer, we are actually extending the range of numbers that we can use. So let's say like you are going to store only marks that is scored in your subjects. Okay, so for that, do we need like a 10-digit number? Because your marks is definitely not going to cross around, like, even if your board exam marks also not going to cross beyond a 4-digit. So if it is that's the situation means, so why do we need to go for a 4-byte integer size? So we are taking 2 bytes of unnecessary size, right? That's why we can use like 2-byte size integer, that we can call it as a short int. Okay, and for 4-byte we call it as a int. So now let's come to the next part, that is long int. So I can literally say like this is, sorry, for long int, literally say like I can say this is our long int. Now there can be a question that raises about, sir, we are having like int also the same range 4-byte and long int also the same range 4-byte. Reason is, so in the initial stage when we used that 16-bit processor and all, we used only 2-byte as an integer. That means our integer was just 2-byte size and our range was this. So as time evolved, we got like a big processor and all, 32-bit, 64-bit, 86-bit. So they settled to finalize with a number of 4-byte for a normal integer, and for a short int 2-byte, and for long int, that is technically for 8 bytes, we have a range of -9223 372 036 854 775 807. Okay, so this, sorry, 808. So this is the range that a long integer can go. Okay, so from this point to positive side, 922 337 2036 85 775 807. So for an 8-byte range, that is long int, we get this much range. So based on our requirement, we can extend the size that is stored inside our memory block, that is asked from our RAM storage. Okay, so you see, if you are storing your application, based on your application, if you are storing marks, you need this. If you are storing some contact numbers, yes, of course you need this. If you are storing something much more bigger numbers, yes, of course you need this. Let's say like population. Okay, for that you need 8 bytes. In that spaces you can go. So here comes another question, sir, can we go with the long int, a triple long int? No, That is not a possibility. So we can just go up to too long, that's all. And back to our previous question, int also 4 bytes and long int also 4 bytes, because when this at the beginning stage when we use 16-bit processor, integer was just 2 bytes, so long int was named as a 4-byte memory block. But later when we chose our int to be 4 byte, when we got our 32-bit processor, 64-bit processor and all, so there is no further move for our long int. So our long int and our int remains the same memory block size, number range size. And what is unsigned means, when you use unsigned, when you use the unsigned area, so you see here for negative we have these many numbers and positive we have these many numbers. Let's say like I wanna save a number called 62,159. So of course this number doesn't come in this positive range. So what we do, we don't go for short int, we go for a normal int that is 4 byte size. But you just think of this scenario, this is also 5 digit, this is also 5 digit, just we are extending few 10,000s beyond this 32,000, we are situated to go to a 4 byte size. That means for a few more bit of extra number, we are situated to increase our memory size by 2 bytes. So that is not an efficient way to code, right? So what we do means, we'll use that source of the negative side. So you see, if I add this number to this number, we tend to get 65,535. Sorry, 65,535. Now let us think, this was the number that I wanted to save, right? And if I use both the negative and positive ranges in the positive side itself, I'm getting this to be my range. So this is what is called as, so from 0 to 65,535 is said to be a 2 byte size, but the name is not short int, rather the name is unsigned short int. Okay, so just by using an unsigned keyword before our whatever the data type that we are using, it just pulls out the negative ranges to the positive side, and we can extend our range in the positive side for an extra bit. So that using this unsigned short int, are we saving 2 bytes that would have been called unnecessarily? So that is what we are going to learn. And so I just don't want to pull the strings for a long time. So what I will do, I'll quickly give you some idea how to work with it. In the previous session we saw like what format specifier we are using to print our integer value. So what I will do, I'll keep int a is equal to 1, printf, we have to give what format are we going to print and what we are going to print. So if I run this, you can see I'm getting 1. So yes, it is working. Let me give some number that is very much big. So you see, it is having 5, 10, 12 digit number. So if you have noted whatever the range that I have given you previously, presented to you previously, you could come to a conclusion like this is not a number that could be saved inside an int. So if I try to run it, of course I'm getting some random number. So but I would personally not recommend you to call this as a random number. I would recommend you to call it as a looping of any data type. So here we are studying about integers, so looping of integer data type. So let me bring up the range, maximum range that an integer can store. This is the maximum range that an integer can store, and when I run this, you get the number as it is. You can compare it. Yeah, are we getting the same number? Yes. But if I add a 1 to this, see what happening? So you cannot define it to be a random number, right? Our output. Yeah, this is the minimum range that we can get when we are using an integer data type of 4 byte size. Okay, so it is not a random number. When we reach the maximum value of a memory block that is created, and if we try to add a 1 value to that, it will loop and start from its negative value. So from this, you could come to a conclusion like if I do a plus 2, what will be the output? Yes, of course, it goes to a minus 214,748,3648, and there is another plus 1, so that it is getting to minus the 10 digit number ending with 47. Okay, so okay, sir, I don't want to mess with these kind of things. If I give 49, I want to print it as 49. So what you can do, you can give long int. As I said, if you use long int, there is no much of difference. You see, I will get the same number. Okay, let me use long int. If I run this, technically I will get the same, not the same number, but the -214 kind of thing. So those who have some idea would have got what's wrong over here. The format specifier is wrong. The format specifier is said to be a %d. That is a format specifier for integer. But what are we using? Long integer. So we have to put LLD. How are we getting this number? Before you get any previous thoughts of like, sir, what about long int? Okay, let me give long int and let me put LD. You won't get that number. Reason is long int has the same range as our int. So for beginners, let me write that format specifiers that you have to use. %d for int, %h for short int, %ld for long int, which is not gonna do anything much better than our normal int. So %lld for long int, and %u, that is for unsigned int, and %hu for unsigned short int, and %lu for unsigned long int, and %llu for unsigned long int. Okay, so this would do. Just studying this would give you some idea. Okay, so let us come to short int. So let me put it as a short int and let me write it as h over here, and let us try to print this number. But before that, let us comment this part. Okay, yeah, okay, have I did any mistake? Sorry, %ht for short int. So it is rotating one complete rotation. So let me explain it to you. 32767. Are we getting the same number? 32768 if I give means it is going to the negative way. Okay, are you able to understand? So we used short int. You know the short int range which I have given you, which I have presented to you already in the same video itself. So you can see if I try to extend the maximum range that short integer can store, it is obviously going to that negative value. So what I will do next, let us learn unsigned short int. As I said, if you are planning to increase just a bit more of your range, just like adding this 1 over here, that should not affect your range, right? So what we can do, we can use hu and unsigned short int. You can see we are getting 32768. Fine. As I said, it can go up to 65,535 value. And if I run this, just a minute guys, and if I run this, yes, I'm getting this number. So unsigned short integer uses both its negative value range also in the positive side and extends the positive numbers range. So if I try to put a 6 over here, the same rule applies here guys. So what is the range of unsigned short int? Normal short int is having a range of -32768 to 32767, but I'm using the negative range also in the positive side. So what happens is, now unsigned short int range is 65535. Okay, 0 to 65535. So in that case, if I put a +1 here, it will loop, and what is the minimum value it can store? 0, and it pushes to 0. And if I add 2 value over here, that is, instead of giving 35 at the end, if I give 37, it moves to 1. If I give 38, it moves to 2. So it is just a looping of a data type, specifically integer over here. Are you able to understand?